AI is the most powerful technology force of our time, and it's transforming virtually every industry from healthcare and finance to energy and manufacturing. The breakthroughs in AI are nothing short of science fiction, and nowhere is this transformation more significant than in the automotive industry. Autonomous driving is perhaps the most intense AI challenge, but it's also the one with the greatest impact to society. It will save lives, make roads less congested, and fundamentally change the way billions of people move around the world. Transportation is a $10 trillion industry that includes not just passenger vehicles, but also commercial trucks, robo-taxis, delivery vans, and even specialized vehicles used in agriculture, construction, and mining. In the past, passenger vehicles were defined by their driving experience, where a key capability was simply its horsepower. But now, advancements in deep learning and robotics technologies are redefining the auto industry based on a vehicle's computing power. Eventually, everything that moves will be automated. These future cars and trucks are going to be completely programmable computers, and the business models for the transportation industry will be entirely software-driven. This tech mindset will fundamentally see a car not just as hardware sold, but as an installed base where the entire fleet gets new services over the life of a car. But I want to explain how profoundly challenging it is to develop self-driving cars. First, you need a high-performance computer architecture and sensor suite in every car. A self-driving fleet will generate many petabytes of data each day, all of which needs to be encoded, secured, and then sent to the cloud. We have to label this data to identify every object, lane marking, and traffic sign, and then train deep neural networks on that data set. These AI models are then tested on a full range of scenarios in a digital twin of the real car. This entire process is never ending. This way of developing software is profoundly different from the way software was developed in the past. It requires supercomputers in the data center and supercomputers in the car. This end-to-end data factory is the very essence of NVIDIA's self-driving car initiative. Because autonomous vehicles are such a grand challenge, the companies with the best development flow will be the most successful. AI-powered vehicles will get smarter and smarter over time as the software is trained with more data, tested, validated, and finally updated over the air into each vehicle. To enable this, NVIDIA built and opened the Drive Hyperion platform, specifying a computer and sensor architecture that is functionally safe if one computer or sensor fails. There is a backup available to ensure the vehicle can drive its passenger to a safe place. Validation is critical, but it is really hard to experience all the rare corner case situations on actual roads. That is why we built our own simulation platform based on Omniverse called Drive Sim. We use it to create a physically accurate simulator that is essentially identical to a real car. For instance, in our collaboration with Mercedes-Benz, we completely modeled the EQS to be true to life, including accurate vehicle shape, dimensions, and real dynamics based on the vehicle's tires and transmission so that acceleration, braking, and cornering are perfectly accurate. We can run AV software in a digital twin of the real vehicle, and the car's computer doesn't even know it's running in a virtual world in the data center. I am really excited and proud of the size of NVIDIA's Drive ecosystem. It includes hundreds of companies, automakers, truck makers, tier 1 suppliers, software startups, and mapping companies from around the globe. We are the only company today that has an open platform for the industry to build on. Together, we are developing the core technologies fundamental to self-driving cars, enabling safer travel and extending the freedom of mobility to all.